Different, yep. So you look at the question and it provides you all this information about the parabola, what it passes through, what certain conditions the chord must meet, and so on. Okay, so we'll do that. P stands for. Okay, so we're going to form equations for x and y that rely on whatever parameters we've got. Okay, C stands for. Yep. So we'll combine them. Two equations into one, so then we get rid of all the parameters. Just got y and x, and the last step, of course, is okay. So, and yesterday, by the way, for this particular locus, right? All we did was the first method out of the two for working out the restriction. So we just did the graphical method, the geometric method. We skipped the algebraic method. I'll come back to it today. We'll look at the discriminant because I'm actually going to give you a special example that relates to that. But I'm getting ahead of myself. Anyway, now we're on to the second question. What's the locus of the intersection of the tangents that come from the 2 points we're interested in? Okay, so if we're dealing with data first, okay, data. What kind of data do I already know? Remember, this whole situation is about this parabola, x squared equals 8y. Okay, so I still have the same, a equals 2 that I did from before. That hasn't changed, right? What else did I know about this? What else did I know? Good, yeah. So these tangents, right? It's not just any tangents. It's tangents through these 2 points in particular. And these 2 points are not just any random points. They're actually related to each other. Namely through this, was it 2, 0? Or is it 0?
2, 0.
2, 0, yeah, okay. It passes through 2, 0. So what we did was, we got the equation of the chord, didn't we? And we had to get that from scratch, right? And then we subbed in this point, and we got this guy. Do you remember that? Yep. And then that was the end of our first step. We'd gotten all the data, okay? Now, being that it's still the same chord, right? This still applies. This is still going to be true. Okay, so we'll use that briefly. Now, I can get onto the parametric equations now, okay? So I've got to have an x equals and a y equals, right? And the point I'm interested in, or the points, are the intersection of tangents, okay? So if I'm going to work out where the tangents intersect, what am I going to need to know before that? Yeah, that's right. And just like with the equation of the chord earlier, which led us to this, okay, we have to work out what those equations are. We can't just quote them, okay? Unless the question just says, you may assume. And that, if you've seen some of the past papers, it actually says, you may assume that do not prove, and so on, okay? And you see that the number of marks on the question is lower to reflect that. Right, so equations of the tangents, there's 2 of them. How do we go about finding the equations of the tangents? Let's do the first one. The one at P. What do? What form should I use? I know the point that it passes through, right? And I will also know its gradient because it's a tangent. Okay, so I'm going to use point gradient form. Okay. Now, what did we establish? What were the coordinates? Because a equals 2, right? Some point on the parabola P was, what was it? 4p, 2p squared. Is that right? From memory?
Yeah.
Yep. Okay. So there are x and y coordinates, so we'll pop them in. Y minus 2p squared. Now, gradient at that point is p. That's why we chose the parameter, right? So we've got p out the front, x minus 4p.
Wait, so we don't actually have to prove that these are gradient?
Okay, yeah, no. I mean, that's not an equation in some ways. I mean, that goes right back to the definition of why we said it's 4p, 2p squared. It's because that's the parameter, that's the gradient.
So just use it.
Okay, yeah.
Do you have to write using the same parameters?
Yeah, no. I mean, I've looked through all of the like the marking guidelines and that kind of thing, and there's never a mark devoted to states the definition of p and why it's relevant and so on. Okay, so I think you're fine to go ahead with that. Right, okay, let's just simplify out a little bit. That's going to be px, that's minus 4p squared, and there's a 2p squared that's come from the other side. So, bless you, here's one of the, bless you, tangents. Okay? So, similarly, say that 10 times fast. The tangent at Q has this equation. Okay, great. So now that I've got the tangents, I can actually find their point of intersection. So let's do that. We'll solve simultaneously. So point of intersection. Let each equation equal the other. Okay, so what do I want here? I've only got x's and no y's, right? So I'm about to find the parametric equation for x. Let's just make x the subject, yeah? So we'll get this guy over, px minus qx. Put that over, so far so good. I can factorize and then divide through. I think you can see though that I just have to divide by p minus q, right? Which will leave me with this difference of squares. So this will be 2p plus 2q. Is that right? Great. So one parametric equation done. How do I find the other one? I'll sub it back in. What should I sub it back into? Yeah, either of these doesn't matter, right? Because both of them intersect at that point, so they should satisfy for it. So y equals, I'll just take the first one, p times x minus 2p squared. Yep. 2p squared there, 2p squared there, so they cancel. That leaves me with 2pq. Okay. Now, here's one of the advantages. You're like, why did I bother memorizing all those results that are in the program for like intersection of this and chords, blah, blah, blah. It's not so you can quote them. It's so that when you get to this point, you can recognize, okay, that the coordinates of the intersection of the tangents are a outside of p plus q. That's the x coordinate. And the y coordinate is apq. We already knew what a was, right? So at this point, it's just sort of a helpful check for yourself. You're like, yeah, good morning. I'm on the right track. We're all good so far, okay? Great. So data, done. Parametric equations, done. Cartesian equation. How do I put them together? Now, in previous questions, because what you end up with, the final locus you get, is a parabola, right? The way that you combine them will involve squaring in some way, okay? Because this has to have a degree of 2, that locus, right? But when you look at how this x equation and this y equation relate to each other, there are no squares, right? This is linear in P and Q, and this is also linear in P and Q. So I don't need to square anything. So what should I do? Yeah. I could do that, but I feel like it's doing extra work we don't need to, especially given that the reason why we did this step is precisely to allow us to put these things together, right? So if 2pq is equal to p plus q, right? I can put that into this line, right? Y equals 2 times, sorry, not 2 times. I've already got the 2. It's just p plus q, right? And you probably should say, you know, from equation, whatever we named it. I can't remember what we named it.
Is this
You know, it was like the first result I got, right? Yeah. So does that make sense? The reason why I can use it is because that comes from the same setup, same question. Okay. So now, how do I relate that to the x? Well, that's half all of this. Okay. So that's x on 2. Right? I'm finished. That's it. That's the locus. That's the Cartesian equation. Okay. So I've done this. I've got this. Now I've got to work out a restriction. Okay. So like we said before, you could use the geometric proof, or you could use the discriminant. Because we've already got the graph here, I'm just going to draw this in. Y equals x on 2. Right? Where's this going to go through? Well, if I draw this accurately enough, oh, that's terrible. Oh well. There's my feeble attempt at x on 2. I know it actually goes through that point because that's 4, 2, right? Which lies on the line. Okay. So what is this point that we're trying to find again? This locus of points is the intersection of the tangents, right? And wherever your tangents go, where they intersect must be outside, okay? So what domain am I interested in? No, I didn't. Thank you for reminding me. We'll go check it. But regardless, instead of inside, which is what I had before in the first part, because it's the midpoint, I want the outside. And over here, okay? Which, interestingly, without doing any work, is exactly the same restriction as the first question, Okay? The restriction is it's less than or equal to 0, or not inclusive, depending on what we work out, and greater than or equal to 4. Okay? Now I'll let you have a think as to why it's so convenient that the restriction works out to be identical, though for the opposite reason. Okay? But that's the question. Okay? So maybe the crucial step was realizing you could use this from the first question. A lot of people forgot that. They're like, oh, I thought this was related just to the midpoint thing, right? It's not, because it's the same chord that presupposes all of this. Okay? So it's the same condition.